Hey, what's up, Gomez gang? Today we are talking about the Lesson 8 exit ticket for Unit 4. Two simple questions that we should be getting correct. We need to make sure that we understand this concept. Now, what this exit ticket is trying to assess is your ability to understand whether two expressions are always, sometimes, or never equivalent to one another. Now, we've done a couple examples on the board, but here we are discoursing the ones that we have done today. Firstly, I have 3 plus 4n minus 2 plus 2n on one side. And on the other side, we have 4 plus 5n minus 3 plus n. So far, so good. Now, I can simplify this a lot easier. I know that I have a 4n that is positive and a 2n that is positive. So I can combine like terms and have 6n. Over here, I have a positive 3, but I am subtracting 2. So if I have 3 and I subtract 2, then I only have 1, a positive 1. Many people forget that this is a negative 2 or that I am subtracting 2 and will make this 6n plus 5, which is incorrect. That is my left side, is as simplified as it can be. Over here, we're going to do the same thing. I have a positive 5n and a positive n, which means I have 6 n's. Over here, I have a 4 and a negative 3, which means 4 plus negative 3 or 4 minus 3 will also get me to a plus 1. Now, when they are both simplified, it doesn't matter which value n is. They will always be equal to one another. For example, let's try 3. 6 times 3 is 18 plus 1 is 19. 6 times 3 is 18 plus 1 is 19. These expressions are already equivalent. So regardless of what n is equal to, they will always be equal to each other. Now, for question 2, it's slightly different because they're already pretty simple as it is. We have 1.5q plus 5 is equal to 1.5q minus 5. Very straightforward. And if I wanted to plot this, hypothetically speaking, on a number line, and right here we have 1.5q plus 5. That is where we are at the moment. If I wanted to get to just 1.5q, because both places, technically speaking, start at 1.5q, I need to go a little back. I need to go a little back to get to 1.5q. In fact, I need to go back 5 spots. That's how we get to 1.5q. Sorry if you cannot see. Hopefully this works. So now I'm at 1.5q. So here is this expression. But now I need to find 1.5q minus 5. I still need to subtract 5 from here to get to 1.5q minus 5. Therefore, it doesn't matter what q is equal to. These will never be equivalent to one another. In fact, the first one, or the one on the left, will always be 10 greater. It will always be 10 greater because this one would be adding 5, whereas this one would be subtracting 5 from the same original value. Those are the constants, the 1.5q that is staying the same in both expressions. However, one is adding 5 and one is subtracting 5. And because they have different actions from the same constant, they will never be equal to one another. Let's try and check our work. If I said q is equal to 1, then we have 1.5q. 1.5 times 1 is 1.5, plus 5 gets me to 6.5. Now, if we do 1.5 times 1, which is 1.5, minus 5, that will get me to negative 3.5. Those answers do not match. So right off the bat, you know that it will never be always, because I just proved the way it will not be. I hope you guys enjoyed.